Okay, my high grade workshoppers. So you should have had enough time to do this for yourselves. So I'm going to review these long answers with you. So these will be at the back of paper 1. And at the back of paper 1, you will be required to do 15 marks. 3 of them could be 5, 4 or 6 markers, but they'll tot up between them to 5. These are all new spec examples. And you can see the level of detail required in the mark scheme is much greater than the practice ones you would have done in first year on these topics. So this first one you have to watch out for is actually a two-parter. We need growth structure of the lung and ventilation. So it's 2 parts. Okay. So this first answer, we know straight away they are not going to get all marks because it's just not long enough. Okay, so we're thinking about a page of A4 writing is about the length you'd need for a 5 marker at the back of paper 1, which I know certain people in my classes still struggle with. Okay, so you really got to push the detail. So the first one we're looking for, the first mark point, is name structures. So they've got to have the trachea, bronchi, bronchioles and alveoli all mentioned in the correct order. Okay. So if they're not in the correct order, you don't get them. So in that first answer, the only one they've named is the alveoli. So they don't get that mark point at all. If we have a look at question answer 2, it's a bit more thorough. So we may have more in there. So we have got trachea. So this is the tube. This tube then branches into bronchi. 2 bronchi, one supplying each lung. Within the lung, these tubes branch through into bronchioles, and at the end you've got alveoli. So they're going to have mark point 1. Okay, that's them. And they were in the correct order. Okay, it said if you'd drawn a diagram in the correct position, with everything in the correct position, you could have got the mark point as well. But one other mark point for the correct order. That was it for the growth structure. So that's kind of there, they've done their bit. So looking at the breathing mechanism now in both answers. So there was a mark point for breathing in, the diaphragm contracts, and the external, and it's underlined. So you can't have that mark point unless you've got external intercostal muscles contract. So for breathing in, you need both muscles contracting, you need external intercostals if you look at the mark scheme. The second mark point attached to breathing in is that means the volume increases and the pressure decreases in the thoracic cavity below atmosphere, resulting in air moving in. Okay, you can accept lungs or thorax instead of thoracic cavity. Okay, a reference to thoracic cavity is only required once. Right, so let's have a look at both answers then. So where have they got breathing in here? We breathe in when the intercostal muscles contract and the diaphragm contracts. So unfortunately, they don't get that mark point because we don't know what kind of intercostal muscles. And then increasing the volume of the thoracic cavity was part of a mark point. So volume increases in the thoracic cavity, pressure decreases, lowering the pressure so air moves in. So they can have that 1 mark point there, which is mark point 4. Then we breathe out when the muscles relax and the pressure in the lungs increases. So there's not enough information in that one. Because mark point 5 for breathing out is diaphragm relaxes and internal intercostals contract, or external intercostal muscles relax. But it says you have to have also that the lung tissue is elastic if you go for the external intercostals or intercostals relax. So there's that level of detail there. Okay, which means they're not going to get that mark point 5. And they haven't got the mark point 6 because they've not got the volume and the pressure. So they've got 1 mark. Candidate number 2. Breathing is brought about by the contraction of the external intercostal muscles, moving the ribs up and out, and the diaphragm contracting downwards. So they've got mark point 3. These actions increase the volume of the thoracic cavity, reducing the pressure in the lungs below the pressure of the atmospheric air. So that's mark point 4. Nicely done. Breathing out is the result of the intercostal, so the external intercostal muscles relaxing and the diaphragm relaxing. But unfortunately, the caveat the examiner's put on is if you only do the external intercostals relaxing, you have to say the lung tissue recoils because it's elastic. So they haven't quite got that one. But they have got the change in pressure. So they've got this decreases the volume within the thoracic cavity, increasing the pressure in the lungs above that of atmospheric air. So they have got that last one there. So for this person, they've got 1, 2, 3, 4, 5 of the 6. And you can also see there aren't a lot of spur mark points on these new spec ones either. Okay, right, let's have a look at the second question then. Interestingly, they're doing this again. It's a 2-part 5 marker. So we've got mucus produced in the epithelial cell. The gas exchange system contains triglycerides and phospholipids. Compare and contrast. We have to be careful with those. We know that's a specific instruction. The structure and properties. So the 2 parts we need to address: structure and properties of both. So answer 1. Okay, so in answer 1, they've said they both contain fatty acids and glycerol. However, triglycerides contain 3 fatty acids, while phospholipids contain 2 in a phosphate group 2. Both contain ester bonds and are produced by condensation reactions. Phospholipids have a hydrophilic head and hydrophobic tails. So the first thing you'd be reflecting on is there's more structure than properties in there, which is going to be true for most people's answers because you will have concentrated on structural differences between the two and you've answered that question many times. But because it was a compare and contrast, we focused on the differences. So it's this idea of both. So we're looking for both contain ester bonds. So we have got that. Both contain glycerol. We've got that. Then the next mark point 3 is fatty acids on both can be saturated or unsaturated. Now they haven't written about that. Both are insoluble in water. They haven't written about that. Both contain carbon, hydrogen and oxygen, but phospholipids also contain phosphorus. We haven't got that either. And triglycerides have 3 fatty acids. Phospholipids have 2 plus a phosphate. So they have got mark point 6. They haven't got 7 because in 7 it says triglycerides are hydrophobic and phospholipids have a hydrophilic head and a hydrophobic region. So they can't have that mark point because they haven't done the contrast. And phospholipids form a monolayer, bilayer or micelle, and triglycerides don't. We haven't got either because that's a property. Okay, now sometimes on these where they've got both, they'll limit the number of marks you can make if you just do structure. Now they've just done structure. They've got 3 marks. On the mark scheme, often, if you hadn't mentioned properties, they'd limit your mark at 3. So if you did some more structural differences, they wouldn't have got any more marks anyway. So looking at answer 2. So triglycerides, that should say contain, shouldn't it? So it doesn't make any sense. Contain glycerol and 3 fatty acids joined by ester bonds. Phospholipids contain glycerol, fatty acids and a phosphate group. Both are lipids containing lots of energy, but phospholipids make up cell membranes. The heads of phospholipids are hydrophobic and so align with water, whilst fatty acids move away. Right, so this one is actually even worse. Okay, have you struggled to give it any marks at all? They haven't said both for anything, so the examiner is going to have to fish. There's no comparatives, so literally there are no marks there, are there? They've said both contain glycerol in a roundabout way. So that I might give a 1 up, like, if the examiner spots it, they might be kind to you. Okay, so you can see with that one, people, and you can see from the examiner feedback as well, it was really, really badly answered by students because they didn't know what to write about properties. So when you look at what's on the mark scheme for properties, it is just things you know already. It's just you've never really compared them before. So the fact that phospholipids have this hydrophilic head and hydrophobic tails, we've talked about endlessly. But we've never said, well, triglycerides don't have that, they're just hydrophobic. But you did know that because they're insoluble in water and form droplets. So, and you do know about the biolayer for the phospholipids, or the fact they form micelles. So it's bringing together information from different topics, not just your biochemistry topic. Okay, moving on to the next question. Mucus also contains glycoproteins. One of these glycoproteins is a polypeptide with the sugar lactose attached. Describe how lactose is formed and where in the cell it would be attached to the polypeptide to form a glycoprotein. Answer 1. Glucose and galactose are joined by condensation reaction. Okay, so that's 1 mark. So that's mark point 1 is for the monomer units. Then there is a second mark point there because they said joined by condensation reaction, and they said the bond name, so that's 2, and that's mark point 3. Okay, and then finally they said that the lactose would then be added to the polypeptide chain within the Golgi body. Now, on the mark scheme, it says Golgi apparatus. It does say polypeptide, so that had to be polypeptide. And Golgi apparatus is in brackets, so they have got mark point 4. So actually, even though it's really short, that was a good 4 marker. For the second one, they have got the glucose and the lactose. They haven't got this because they said protein rather than polypeptide chain. Or they've talked about modifying proteins. So although they've mentioned Golgi apparatus, it wasn't the same detail as this one. So they've only got 1 mark. Okay, so one last one to have a look at, another compare and contrast. Your favourite bit of microscope, something you've not thought about for ages and ages and ages and ages. Okay, so answer 1. Let's see if I can get it all on. Optical microscope uses light to illuminate a sample and focuses with lenses. This is in contrast to the electron microscope, which uses a beam of electrons focused by electromagnets. So that is the first mark point. Transmission electron microscope uses electrons and the optimum microscope uses light. We have to decide now whether the examiner is going to penalise the fact they haven't called it a transmission electron microscope all the way through. I don't think they will, but obviously if they say transmission electron microscope, you should be saying transmission electron microscope. Okay, but we'll give them that first mark. Both with an E on the end, I don't know why. Both increase the magnification of the sample. Okay, which is true, they both do that. But that's not worth a mark point. The focused bit is, that's mark point 8. So we do get 2 mark points for that first statement. Both increase the magnification of the sample. However, the light microscope has a limited resolution, limited useful magnification. The electron microscope has a much greater resolution, greater magnification. So greater resolution got a mark. Okay. The light microscope allows you to view living things in colour. So we can have the converse there. So transmission electron microscope does not allow colour. So do they have that? Should really do contrasting. Transmission electron microscope only dead material. Viewed in a vacuum. Easier to use, doesn't need special training. It's a bit too more complex, they said, for the other one. So the issue we've got here is that they're making it quite hard to mark, because if they'd have said the light microscope allows you to view living things, the electron microscope dead things, the light microscope allows you to view things in colour, whereas the electron microscope only gives black and white images. If they do it one versus the other all the way through, it makes it much easier to mark. So they can't have the colour one because they didn't say electron microscope doesn't give colour. They can have the live versus dead because they have put both sides. But they can't have that complex one because it says the transmission electron microscope is more complex, takes more time to prepare, whereas they've said the light microscope's easier to use, you don't need special training. So that's not equivalent. So that's only 4 out of 6. On the last one, they've chosen to abbreviate optical microscope and transmission electron microscope. Okay, now that might be okay because they're in the question. It depends how tight and horrible the examiner needs to be. First time, use the full words and then abbreviate. So we've got light versus electrons again, 1 mark. Living in colour but no contrast on this, so they've not done the other side. Not as good a resolution as so good is not the same as saying greater for the transmission electron microscope. Be careful about that. You could think good was a lower resolution, so you've got to say the transmission electron microscope has a greater resolution than the light microscope. So the transmission electron microscope allows you to view small structures in the cells. Transmission electron microscope needs very thin samples cut by lasers, which can sometimes cause artifacts. Now they have done, you can have the thin one on its own. I don't know why, but there you go. But that's it. So they haven't done the other sides either. So the lesson really in this, and the lesson in this, particularly these contrast, compare and contrast, is you hit the mark schemes better if you say the transmission electron microscope uses electrons, whereas the optical microscope, and sort of use the words in the question, so you don't call it a light microscope if they called it an optical microscope. It means the same thing, but uses light. So you're doing all the time. The transmission electron microscope gives a greater resolution than the light microscope. Therefore, the transmission electron microscope allows you to view smaller organelles, example mitochondria, or smaller things than that, ribosomes, within the cell, or the internal structures of organelles, or something like that. Transmission electron microscope only allows you to view dead specimens, whereas the light microscope, the optical microscope, you can view living specimens. Transmission electron microscope does not show colour, whereas the optical microscope can, etc. So it's that detail level. So we really need to practice for these long answer ones at the back of paper 1. Lots of detail. Okay, hopefully see you next week.